Hi panelists, hi again. So we're the team Fully Charged and we're hacking from the UK. We're a bunch of engineers based in the UK. So a quick summary of the challenge statement, but you guys would definitely know this because you guys set the questions. So it's just that the construction in the US generates a huge amount of waste, and we must sort of redesign the entire construction process to increase value to sort of recycle the building materials. So underpinning the problem, first we were looking at shipping container houses. That's what we first came across and we thought it was a really good idea. But we wanted to increase customizability by like making sure that one container isn't just one home. And by reusing such non-seaworthy shipping containers, we can add around 15 years of lifespan to the shipping containers. So these shipping containers are built for weather protection, but we have to repaint them and we have to remove the rust for it to be used again within construction. So as you can see on the picture on our right, so with our design, we aimed for customizability and easy disassembly. We would retain the traditional timber frame of the stick-built houses and then sort of build in tracks to slide in the shipping container panels and followed by applying a seal. So because the main structural loading will be handled by the timber frame, the windows can be cut in the panel or entire glass pieces can also be slid on the tracks, offering consumers more choice.
As a typical stick-built house, the timber frames are firstly built for the load-bearing purpose. Timbers are cut to size, which can benefit from mass production to save both energy and time. Timbers will be connected with the woodworking joints, and the mechanism will be explained in the next slide. The wall panels are disassembled from discarded shipping container. Then the panels are cut to size. The picture on the right shows how the panel walls are acted as the outer case of the house. The steel tracks are built along the horizontal timber to fix the panel wall between the upper and lower timbers. Next slide.
So for the construction of our house, we drew inspiration from a traditional Japanese style of carpentry called miyadaiku, which allows houses to be built without a single screw or nail. This is done by connecting intricately designed joints, which fit perfectly together. Houses built this way are sturdy and can last more than decades. Modern technology allows for the large-scale production of these wooden beams. For instance, precision milling could help achieve the high level of detail needed in the joints, and modeling softwares could help visualize how the joints would fit together. During this assembly, since our design did not use much adhesive, screws, or nails, the steel panels, insulation layer, and wooden frame are self-contained layers. This allows the components to be reused or recycled in their entirety, rather than having to break them down into much smaller pieces, which would result in a lower quality recycling product. Next.
The design is highly customizable, especially in two aspects: the optional thermal insulation and high freedom of house design. Based on the location, the customers could have the option to install one layer of thermal insulation in their houses. The insulation material will be the cork, and using it will benefit from low cost and negative carbon footprint. The picture on the left shows a container room with thermal insulation installed. Also, customers have high freedom of house design. The picture on the right explains this. The assumed floor plan has a corner on the left, so the tracks will be built in pieces following the shape of the room. Therefore, the new room has not to be the same as a traditional container room, which is always in a rectangular shape. That's it. Thanks.
In order for our proposal to become widely adopted, both the industry and policymakers must make radical changes. First, industry must define circular economy, design framework, and principles. They must also collaborate with other companies by holding industry and client workshops to help identify challenges. Companies must also educate their workers by holding internal workshops and staff training programs. They must also encourage innovation through various industrial competitions. As for policymakers, they must include design for disassembly concepts in building standards such as LEED, GREEN, and the National Green Building Standard. There must also be different economic incentives to incentivize the industry to switch to greener construction and deconstruction techniques. And they must also fund research to look for better and more advanced materials. In conclusion, we suggested a novel reusing of shipping containers idea, and we used precision manufactured wooden sticks assembled using Kawasugi technique, which eliminates the use of bolts, screws, and adhesives. This will promote circularity in the construction industry. Thanks a lot.
Thank you.
All right, we will now move on to the 5 minutes of Q&A.
Do you guys have an idea of how many shipping containers would be thrown away or that are available each year, or a certain time frame for this? I'm just curious, like how significant of a waste stream are the ones that are no longer seaworthy?
It is quite a big waste stream. I think around sort of, I know sort of the magnitude is like around the thousands of shipping containers, 10,000 shipping containers, like on the sort of 10,000 shipping containers are being sort of like thrown away each year, because there's very strict standards about them being seaworthy, but there's the relative construction standards for shipping containers are less than the seaworthy ones.
And to follow up on that, I guess I'm wondering what does the end of life of a shipping container look like? Like what happens to?
A lot of them are just sold as like secondhand shipping containers, which are just used for storage without sea freight. So there's a steady supply of shipping containers that we can use for construction.
And are they still in good quality? Like, is the maintenance difficult, or if they're sold off for other applications, how come they're no longer still being used for their existing application?
Because most of them are for sea freights. A lot of them you can't there's a lot of rust going on, and the weather changes are a lot more dramatic on the sea than like if you just put it in a place for housing or storage. Mm-hmm. So that's why it's a lot. So the life of a shipping container is normally 30 years if it's just fixed in a place, but only 10 to 15 on the sea. So that's why we thought we could use this. And the process of making it suitable for construction would just be because we have to repaint it to sort of remove the rust caused by the seawater, but that's it, because the structural integrity is quite strong and the regulations make it very stiff for us to use.
Okay. Cool. Yeah, I mean, it seems it's a really interesting strategy because you've clearly focused on something that's already designed for manufacturing and has very strict kind of constraints in terms of dimensions. I think it was really interesting to see you guys are also focusing on Japanese carpentry techniques and how you didn't want to use nails and avoid additional material waste in that regard. I'm wondering, what brought you to that conclusion, and how you see it interacting with the materials that you chose. Like you started talking about the ceiling insulation panels and things like that, and I was just curious to hear more about your logic behind that.
So I can first talk about why we chose the shipping containers. Is because instead of trying to recycle something brand new made for construction, mm-hmm. by giving a second life to the shipping containers, I think it's really good. And I think Alice can expand on the Japanese carpentry.
Yeah. So why we wanted to do Japanese carpentry is because we realized that in assembling a house, a lot of the material is wasted because, for instance, let's say you have nails and wood, so that would splinter your wood a bit when you first strike the nails in, and then the corrosion of the nails would also affect the wood quality. So you can only end up grounding your wood down into chips for use, and so the quality of the product that comes out after recycling is really low. And we wanted to avoid that as much as possible. In terms of our material choice for insulation, so we chose cork, a layer of cork sandwiched between OSB panels. So cork itself is perceived to be quite a circular material since it only uses the bark outside of trees and it can regrow very easily. Whereas for OSB boards, it usually uses wood waste in the wood processing industry. So what we wanted to focus on was the circularity of everything. How when you use one resource, it doesn't get exhausted and you can easily return it back to the environment if needed.
That's great. Thank you very much. That was a really great response.
Yeah, I think that is about time.
Okay, perfect.